In this video, we'll show how to measure porosity using some resources that are in Backpocket Grower. So in your browser, go to backpocketgrower.org, click on the Sign In button at the bottom right, and enter the password for the class. Click on Sign In, and now you can go to Tools or Training for resources related to porosity of growing media. First, let's have a look in Training. Go into Training, then Root Substrates, and select Porosity. You'll notice that there are a number of other quality control tests. The fact sheet that we're going to focus on is the rapid porosity test for container substrates. It's set up like the other fact sheets within Backpocket Grower. So there's a goal for this type of test, which is to rapidly measure dry bulk density, water holding capacity, and air porosity of a container substrate. And associated with this fact sheet, there is also a calculator app under Tools. So why is porosity important? It's important because it's the mix of water and air that are going to affect both the availability of water to hydrate a plant and also the amount of air for root respiration. To measure porosity, then you can do that either with a plant that is already rooted into the growing media in a container, or you can do it with fresh root substrate. You're going to need a series of very simple pieces of equipment to do a porosity test. For example, an empty pot of the same type that you're using as the filled pot, and a kitchen scale. The first thing we need to do is to know what the volume of our container is. We place a plastic bag inside the container. We weigh the container and the plastic bag, and then we fill that container up to the level that we'd normally fill with root substrate. We fill up with water. Now 1 milliliter weighs 1 gram. So the weight difference will tell us what the volume is of our container. We then prepare our plant by removing the shoot, so there's just the roots left, or if we're using root substrate, that doesn't apply. And we're going to put our substrate into a container that's lined with the plastic bag. This means it can't drain. We then fill that container with water. That is going to fill all of the pores, all of the holes between the particles with water. So 100% of the pores will be filled with water rather than air. We take that weight. We then allow the container to drain by piercing holes into the plastic bag. And we tip the container side to side so that it drains very well. We weigh it again. And finally, we allow our substrate to air dry, and we weigh the dried substrate. Now there are a series of calculations that you can do that are listed here, but there's also a calculator app, as I mentioned. So here are the information on how to do the calculations, for example, with your phone. But we can also go into Tools and Container Porosity and use the calculator app that's here. So the empty container weight, for example, might weigh 50 grams for the container with a plastic bag. We might have measured the volume and found that it was 1,000 milliliters. If our weight of the container filled with the root substrate and with the drain holes blocked, and where we've filled it up right to the substrate surface level with water, so all the pores are filled with water, let's say in this case the weight was 1,050 grams, and now we have pierced the drain holes and let it to drain down. and we reweigh it at 900 grams, and we have taken the substrate out and let it air dry in the greenhouse for several days, and we weigh it and find that it's 150 grams. Then in this case, we would have 700 milliliters of water being held by the container. We would have 15% air porosity, 70% water porosity, and the remaining volume would be 15%. The dry bulk density of the substrate would be 150 grams per liter. So just to review, how did we get those numbers? The water holding capacity is 1050 minus the weight of the container, 50, minus the amount of water that drained out, which is 150, minus the weight of the substrate, which is 150. So 1050 minus 350 would give us the 700 milliliters per pot. We found that when we opened up the drain holes, 150 milliliters of water drained out. The weight went from 1050 down to 900. That gives us 150 mils, which is 15% of the 1000 mils volume. The water porosity is 70%. That's 700 milliliters divided by the volume of the container, 1000 mils. The solids are calculated by taking 100% minus the air porosity minus the water porosity. So 100 minus 15 minus 70 gives us 15%. The dry bulk density was the weight of 1 liter of substrate that we weighed out when we had allowed it to air dry. So these are all simple calculations to make, and they're all based on the same protocol that is under training.